been very opinionated about is how applications get built should be as similar to the way that applications have previously been built on other network or on other cloud service providers. So in other words, not having to think about things in this like deeply decentralized context and all the like consequences that come from an application design trying to compensate for those differences, but instead something that is so similar to what they do that it basically is almost no different. And so I'm going to demonstrate that a little bit today by talking about two of the things that people do in application design. And the first is going to be the nature of building a decentralized app on another network, for example, like Ethereum, and then how that actually plays out in centralized components, and then how Quilibrium can be used to replace those centralized components into a fully decentralized application design. So to start things off, let's talk about your basic, let's talk about one of the most popular decentralized apps. We'll let's look at Uniswap, for example. So Uniswap is basically comprised of a few small pieces. Uniswap is probably one of the like nicer examples because almost all of it is happening on the given network that it resides in. But there's still one very important component to it, and it's actually been one of those things that's been subject to a lot of litigation, is the fact that there is a centralized front end, and there is a fee component of it, of course, that you can simply ignore if you're just using the back end over on the smart contract side. But generally, when you build a decentralized application, it ends up following this kind of pattern of having the front end being put on S3, GitHub Pages, just some kind of static file host. And then you have the actual smart contract. And then if there's any sort of things that have to happen that are basically leveraging on-chain data, what you end up doing is you'll have like some tertiary indexing service and then another backend service as well that is interacting with that indexer to perform some sort of operation. And of course, this particular smart contract host in this case is Ethereum, but it can really be any sort of chain. It doesn't really matter. It's just whatever is the substrate for decentralized applications to be hosted. So when we're looking at this particular structure, the difference in how you can actually take these centralized components and move them into the decentralized world is very easy with Quilibrium because the way we've exposed these services. We've created an S3 compatible API that enables you to interact with it no different than you're interacting with S3. There are some caveats, and that's what I was talking about earlier. So when you have an S3 bucket, generally you have one of two varieties. You have one that is either private, where all of the contents of that bucket, list operation, every operation you would perform on it is essentially based on authorized access only. When you have that, there is obviously an issue. You can't host a public website on it. So instead, you would, if you were doing a static site on S3, you would make a public bucket. Now, if it's a public bucket, you have an interesting problem for somebody who's trying to make this on, or to put this on a privacy-preserving service like on Quilibrium's Q console. And what that comes down to is, well, it's a public bucket. How do we expose that? So the S3 compatible API basically gives you an option. If you want to do a public bucket, you can, but you are explicitly giving Quilibrium Inc. the decryption key for that given set of items in the bucket. Because otherwise there's no way for a public API to surface this in an unauthenticated context. There is also other options. You have the ability to utilize the S3 API in a completely like privately hosted context. And the way that this basically works is as follows. So if you put a file into our S3 API, you are literally just like taking a random file, like let's say you created a bucket, and then you put the file, like the object, on that S3 bucket. What happens behind the scenes is that object is being broken down into its concrete metadata. Obviously, there's different attributes of a object in S3 parlance. And in order to maintain API compatibility, we have to represent all of it. So that comes down to things like the E tag, of course, but things like the actual object tags that you can put on it. I know not every S3 compatible API supports this, we do. And all of these things are different fragments of information that get turned into verifiably encrypted data. Now, we covered this in the previous broadcast about what verifiable encryption looks like and how that actually gets stored. But what I want to focus on is the underlying pieces that come out of it. So in this structure, you have the actual encrypted blob, and then you have the associated proof data that comes from it. Now, what we care about when we're providing a public bucket, you're basically creating all these encrypted blobs, and then you have the associated metadata names that come with it. So we basically have a particular set of vertices that we are looking for and assign, and we basically assign that such that we are providing that metadata and exposing it to the public API service. And so our public API service essentially, gives an endpoint similar to Amazon S3's various regions, but it's just a singular region. And that's essentially a proxy service that when you receive a request, you have cached metadata up front that denotes buckets, bucket names, file names, and other associated metadata that we would care about exposing. So like things like content type can be generated on the fly. And then from there, it goes to find that particular bucket, grabs that associated decryption key, and then proceeds to fetch the relevant encrypted blob, proceeds to decrypt that encrypted blob, and returns the restored result. If you would rather have a private bucket, like for whatever operations you are doing as a business, then you can use the private buckets and you don't need to utilize this proxy at all. This is just literally to expose a bucket for reasons that you would want to do so. So in that scenario, you could actually sidestep this entire thing. And what we have is basically a local API that a company can have running in their own infrastructure that and it can actually even be embedded in an application. And what it does is it provides that surface area for your S3 SDK to interact with and integrate with. And it will do all the operations that that public bucket proxy is doing, privately configured to you so that you are actually maintaining that strict trust boundary where Quilibrium Inc. is not involved at all. We just simply made it easy for you to manage this. The other thing also is if you do want to have the public bucket, but you don't want the files to actually be public, you only want the easy cached access identifiers for it, so you want the public URLs, but you want to use signed URLs so that you can allow somebody who has that particular decryption key to access it, that's totally possible. And that is another way you can, again, augment your trust boundaries accordingly. And so what that essentially does for you is it gives you, well, basically an S3 API. So let's take a look at what that actually looks like. Okay. Cool. Just wanted to make sure that this is popped up properly. Let's get this increased in size. All right, so I have the local S3 API running, and if I were to interact with it, I've already set up an authentication key for it, so that that particular step of the process is pretty straightforward. You just simply configure that when you're interacting with the API. So I have it exposed currently through localhost 8080. And when I curl localhost, it does the list all my buckets and gives you the name of the account and the associated ID, which is the public key. And that tells you, whatever buckets you have. And you can see right now there are no buckets. So let me Let me go ahead and use the API real quick to create a test bucket. You can see that I've run this before, but... And you're going to see me make the same mistake I made before. Great. There we go. So S3 MB, S3 test bucket. If you want to use the raw S3 API, it's the S3 API command through the AWS CLI, but for the sake of demonstrating like even the easy use case, there we go. We have a test bucket. And when we curl it, we now have that test bucket listed with its creation date. And so the next thing you would do, of course, with a given test bucket, by default, it is a public bucket. So if you want to configure that accordingly, be sure to configure that. But when you have that bucket, you would then want to put something in it. I need to actually make a file first. So let me just do test file. And we will have that. And now you can use the S3 API to proceed to add that file to the test bucket. Okay, and so now we've copied that file. The next thing we can do is, of course, because this is creating public bucket entries on the local API, of course, you can now curl it and you get it. The other thing that you would want to potentially do is utilize the tagging feature. And I can never for the life of me remember that. So let me see where the, oh, this is for bucket creation, my bad. And this is literally what I mean when I say like you are interacting with it the exact same as the raw S3 API. We strive for as much compatibility as possible. There are some circumstances where you can't have that, but we try our best to actually have it. So this would be AWS S3 API, put bucket tagging, bucket test bucket, and then tagging tag set key foo value bar. Oh, right, I need to actually have the endpoint specified, of course. And there we go. Similarly, when you're actually fetching the bucket tagging, you would do the, or sorry, bucket tagging. You would do the corresponding get operation. And like I said, I can never remember these. I always have to end up looking them up myself because there's just so much. And of course, there you go, your tag set. And that's basically it. So structurally, like these items are encoded onto the hypergraph following the given structure that's defined given the RDF schema that was created to provide this S3 compatibility layer. This REST proxy is basically on the fly dispatching these requests to query the hypergraph if it's not cached already as a result, retrieve those objects, decrypt them, re-encode them as the given RDF target types, and translate them to the given JSON structures that they need to be represented as in order to appropriately return a response. That's basically it. So that's the S3 API, and this is one of the things we're going to be exposing through QConsole very shortly. I know some of you have already taken a look at the updated Quilibrium website, and I've already heard a lot of heavy contention about that, and I definitely appreciate the feedback, and we are going to revisit that redesign. We definitely missed the mark on that, and so we'll be moving to something that should be better, but alongside that, we'll also have the link to the QConsole on the build tab at the top of the nav bar. So keep an eye out for that. That's where you'll be able to find it.